All right, so we just talked about number 27 on the page before this. We are solving an equation that has absolute value bars. We made a note that if you have an equation with absolute value bars, that means we will have two solutions. All right, so when you have absolute value bars in an equation, you need to get this alone. I can see the bars are being multiplied by 3 and subtracting a 2. So when we're solving, just follow our solving steps, always starting with the addition or subtraction. So I'm going to add 2 to both sides because negative 2 plus 2 is 0, so we get to cross that off. Carry down 3 times the absolute value of n is equal to 12. Again, we are trying to get this alone. It's being multiplied by 3. We will divide by 3. 3 divided by 3 is 1, leaving us with the absolute value of n is equal to 4. Once you get the absolute value bars alone, this is when we split into two equations. Whatever is on the inside of your bars, in this case it's just an n, so it's a little bit more basic, but if this was a 5n or a 2n minus 1, whatever's on the inside, we're going to write equal to 4, and then we're going to write that equal to a negative 4. In this case, there's no solving to do beyond this because n is just alone. So we have found our two solutions. So let's see, n is equal to 4, and n is equal to negative 4. Or you could write that n is equal to a positive and a negative 4. So absolute value equations have two solutions. It's really easy to forget this second one because you'll get n equals 4 just naturally, but we have to remember, oh, what's the other one? And that's how we get the other one. All right, number 29, write the slope-intercept form of the equation for the line. So just a reminder, slope-intercept form is y equals mx plus b. And if we look at our multiple choice options, we can see those are all in slope-intercept form. So if you're looking at a graph, you just need to identify the slope and the y-intercept. So let's start with our slope. That's the m. You can just count the slope on your graph, the rise over the run. We always start with a point on the left, which is going to be this point right here. And then we do the rise first. So I can rise down or I can rise up. So we're going to rise up however many units it takes to get in line with our other point. So in this case, it's up 1, 2. So it's a positive 2 because we rose up. Then we're going to run to the right 1, 2. So our run is 2. So slope is rise 2 over run 2, and that reduces to a positive 1. And then we just do a slope check. We got a positive slope. We have an uphill line reading left to right, so that checks out. If our line was downhill, we would need a negative slope. We just need to make sure it matches. All right, now the y-intercept is where your line crosses the y-axis. In this case, it's this point right here at negative 1. So our y-intercept is negative 1. So I'm looking for an equation. Well, I guess we can write it. Y equals mx plus b. So y equals, our slope is 1x and our b is negative 1. So y equals 1x minus 1, or in this case, just x minus 1 is the same thing. All right, so now we're going to write slope-intercept form without matching it up to an answer key, not an answer key, a multiple choice option. So y equals mx plus b is slope-intercept form. Let's look at our graph and identify the slope first. We're going to start with a point on the left. We're going to do the rise. In this case, we are rising down. 1, 2, 3, 4. Anytime the rise is going down, you're going to have a negative rise, negative 4. We always run to the right, so your run will always be positive. 1, 2, 3, 4, 5, 6. So our slope is negative 4 over 6. If we can reduce that, we will. So we'll reduce our slope to a negative 2 over 3. We just divided both of those by 2. Now the y-intercept is where does our line cross the y-axis? Here's the y-axis. Here's where we're crossing the y-axis, right there at a positive 2. So the y-intercept is at 2. Now when we put that all together for slope-intercept form, y equals our m slope is negative 2/3 x, and our b y-intercept is a positive 2. All right, now we're just going to graph a couple of these, get practice doing some graphing. Let's see, both of these are in slope-intercept form, so we'll just be thorough and let's identify the slope is the number in front of the x. So this has a slope of 2. If it helps, make that a 2/1 so you can see the rise over the run. And then the y-intercept is at a negative 4. When we graph this, you start by graphing the y-intercept. That's going to go on the y-axis. Don't put it on the x-axis. That's a mistake I see sometimes. It's called a y-intercept, so it has to go on the y-axis. We're going to plot a point at 4. Then from there, we do our slope of 2/1. So this is the rise 2. That means we're going to go up because it's positive, and we always run to the right. So if we're here on the y-intercept, we're going to rise 2, run to the right, and put a point. Rise 2, run to the right 1, put a point. Up 2 to the right 1, up 2 to the right 1. So I'll go ahead and fill in those points. Once you have your points plotted, we will draw in a straight line with arrows on the end to indicate that this line does continue forever in both directions. All right, so we have one more graph, y equals negative 3/2 x plus 2. Actually, I didn't mention this on the one before. Our slope was positive, and do you see how when we read our graph coming in left to right, we are heading uphill, so that line would have a positive slope. We just want to make sure that those things check out. All right, so now our slope is a negative 3/2. This should be a downhill line when we graph it. Our y-intercept is equal to a positive 2. And then we put some points on our graph. Always starting with the y-intercept on the y-axis, right there. And then when we do our slope from the y-intercept, we're going to go, the rise is negative, so we're going to go down 3 and to the right 2 and put a point. Down 3 to the right 2, put a point. And then to get the left side of your line, the line that's on the left side of your y-intercept, you just do the opposite. Instead of going down 3, here's where you go up 3 and to the left 2. All right, once you have your points, you will draw a straight line, arrows on the end, because lines continue forever in both directions.